computer with audio, one has to assume that this is up and running, I hope. I've got a worksheet going on the assumption today is Saturday. Our class isn't until Monday. I'm going on the assumption that we've covered a good deal of these topics. Anything that I didn't get to, don't worry about. You'll hear it for the first time now. All right, and I hope it means more to you tonight if you're working on your homework at night than it did earlier in the day. Okay, and as I say, I'm under time pressure here. It's nearly 10 after 1, and I got to finish this before 2. I've got a phone call coming in. So I might pick up the pace at some point. Otherwise, I'll try to talk a little bit about each problem. And what else did I want to say? Oh, yes, I've got an answer key here. I generated this just about 5 minutes ago. So I didn't write down too many steps where I got caught up in some mathematical calculations. I did a little doodling on the side. I'm saying that because the answers may differ when we do them out here, and hopefully not. I feel pretty confident most of that's right. Okay, so I'm going to get to it. 32 questions, and pause the video if you want to do it with me. If you want to do the assignment on your own prior to looking at the video and then checking which ones you got wrong, that's fine. But I will always be layering each question during the course of the summer school session with commentary. So there's always something to be learned. And actually, I'm changing my language on one of the types of topics that we'll be covering, conversion. I'm going to be talking about generated change. And that's a new language for me, and I think it fits better. But we'll talk about that as we go through the term. All right, so I think the first one was write the equation of the line through these 2 points. It's nice sometimes to put it in tabular form because you can see you go up 5 in your x's and it looks like you go down 81. See, I already made a mistake. I said 81 in the answer key there. It's 71. So right off the bat, I can see that, I'm trying to hurry as quickly as I was. So look for that. In fact, I can change that right now. So I got to convert it at 99. So I'll get rid of 99 because I really want 100. And I know that the generated change here, when I drop a 29 in, is minus 71. So I know I've got to go down 71 units from 100 to get to 29. And that's the change in y. The generated change in the input is when you drop 104 in here. 104 minus 99 is a generated change of 5. We divide that out to bring the change in that we want. There, I think I'm up and running again. Think I'm better now. Got started. All right. So slope-intercept form. So the only reason I'm doing this is to make sure that your fraction work gets good and quick. So minus 3 times 5 is minus 15. And then we got to divide that amount by 7. And the number 2 can be written as sevenths. That's right. 7 times 2, 14. So slope-intercept form is minus 3/7 x. Minus 15 and 14 is minus 1/7. Same calculation as that. We tend not to use slope-intercept in the higher level math classes. We tend to use really point slope, but I think this is better than point slope. You can see pretty quickly -5 gets you 2 and how things are changing here. All right. All right. So let's move the video, the computer. Video goes with it. And okay, I hope we talked about what works. Well, making a 0, 5. If the right side equals 0, I guess y better be 2. All right, so that gives us an initial condition, if I talked about grandma, 91, 5 hours from now, she's 2 miles north of the border. Hope I talked about that. We'll see. And then we talked about in class, I hope, what that means. Okay, so my x's are changing by 11. So 16, 27, right? My y's are going down by 80. So minus 78, minus 158, I think. That's what I believe is happening there. Writing this as a product, well, we have 2 times m minus m. I hope I put 7 there. Looks like 2 of them are common. So we can take that out and say, okay, I need to multiply that by 2. and I need to multiply it by minus m to the fifth. That's the, that's the first step in writing products. And I hope we talked about earlier in the day that that's not what somebody would ask you in a textbook. They'd ask you to factor that. Well, you're writing sums and differences in terms of multiplication. It's useful when we start dividing out some common quantities. All right, minus 2x minus 9. That's slope intercept. Always good to do things from two perspectives. So I'm dropping down at a 2-to-1 ratio. Over here, I'm up at 20, going up at an 8-to-1 ratio. Sure looks like we have an intersection in the third quadrant, so both of my x's and y's should be negative. But we're only solving for the x right now. So we're looking for an x value that looks to be somewhere near -2, maybe. I don't know. Let's find out. Subtraction of 2x on the left is addition of 2x on the right. Addition of 20 is subtraction of 20 on the other side. So minus 3.9 is acceptable, or minus 39 over 10. Okay, so I said, near -2. Well, I'm a little off. It's near -4. But it's nice to do things from two perspectives. All right, so now we got 3x squared equals 7x. Let's do it from a graphical perspective. 3x squared is a very narrow parabola, and 7x is going up pretty quickly. Looks like we have an intersection at 0, and at some positive x value, that's pretty small. So how do we do it? Well, it's nice if we can set products to 0. Very helpful. And if we can write that product, we can look at the factors that produce the 0. What's common? X. 3x minus 7 equals 0. Oh yeah, x could equal 0, or x could equal 7/3. That's where this quadratic, fancy name for a rectangle, equals this linear calculation. Fancy name for a calculation is a function. All right. I think I had to actually do a doodle on the side. I couldn't do that one in my head. So we're going to multiply by 6 because 3 goes into 6 nicely. 2 goes into 6 nicely. And if you multiply numbers, each number by the same number, it's still an equal equation. And if we multiply this by 10, 2 goes into 10, 5 times 4, we actually get the same result. So I'm going to multiply everything by 6. All righty, and let me get my eraser and have that follow around. We're on the 7th problem. It's taken me 7 minutes. We're on good pace here to get me out of here by 2. All right, so what do we have? 3 goes into 6 twice. 2 times 4x is 8x. Minus 12. 9x. Minus 66. I'm going to bring the 8x that side because I don't like dividing by negatives. So I'm going to addition of 8x is subtraction of 8x. Addition of 66. I might have made a mistake there on that answer key. So 66 minus 12 is what this is going to be. I don't remember doing that. 66 minus 10, 56 minus 6, 56. So it should be 50. So x is 50. I'm going to check that real quick here. No, it's too many fractions. All right, so we'll definitely star this one, and I'll change that right now to x equals 50 over here. I think I botched that one big time. 750. Number 1, I think I did something stupid back here, didn't I? Well, I said something stupid, but let's see. Oh, yeah, it's minus 81. Yes, I did a bad addition. So minus 71. Change that. I think I can take the time to do this. Okay, so far so good. Not a great ratio on the old man's part. All right, so this is a system of equations, and this is written in standard form. Standard. Anytime you write an equation in a graphing form, be nice if I brought the computer over. Anytime, let me pin that so you can see it. Anytime I say something in the graphing form, means you don't have to change the way it looks in order to see what the graph is. So how is this a graphing form? Well, by using zeros. If x is 0, y is 7. If y is 0, x is 7/3. Okay, x is 7/3, y is 7. We got a linear function that has coordinates associated with that line. If you put a 0 in for x, you get positive 1/8 for y. That's really small. And if you put a 0 in for y, you get -1/4, twice that. So we have a linear function that intersects in the first quadrant. I better get some small x and y values here. And they both better be positive, or I know I made another dumb mistake, which is quite possible on this video because I'm under real time pressure. So what am I going to do here? I am going to solve for y first. No, I'm going to eliminate y's. I like the elimination method. So I'm going to multiply that by 8. This is problem number 8. Now I'm multiplying by 8. So that gets me 24x plus 8y equals 56. And underneath it, I've got 4x minus 8y equals -1. Now I can add these up, and that eliminates. And I get 28x equals positive 55. So x equals 55 over 28. That sounds good to me. That's near positive 2 for an x value. That looks about right. And then we're going to solve for y. And I like to use elimination as well. So I got to get rid of the x's. So I'm going to multiply this one by -3 and this one by 4, because that's going to cancel that column right there, 12x minus 12x. I'm not even going to write it. 4y equals 28. 24y equals positive 3. So I'm going to get 31 over 28 for my y value. That's near 1. That looks good. That intersecting coordinate looks good. So I'm going to go with that. Putting this in graphing form. I shouldn't have erased it, but that's all right. Doesn't really matter. It's archived. All right, so you're going to hear minus b over 2a throughout the term. I'm going to explain to you geometrically why that's true. I'm going to explain it to you numerically why it's true. And I've got a couple of other ways of showing it why it's true. For right now, all you're trying to do is remember that minus b over 2a is the x value that is significant. All right. So minus b, 8, divided by 2 times 4, 8. X equals 1 is critical here. So 4 times x. If positive 1 is critical, then we're going to say -1, because the minimum value of squaring it comes at 0. And so the completing the square process we'll talk about, but not right now. Just remember this, that process right now, and we've made tremendous gains on day 1. All right, so you put a 1 in, and if you put a 1 in, and I hope you've done this, you've got 4 minus 8 minus 11. So we now definitely know x equals 1 is correct, because we got a 2-to-1 ratio there. There's geometric reasons for that. And so -4 minus 11 is -15, and that's it. And what we're going to learn later when we graph these is we're going to start on the y-axis, and we're going to start at -11. I'll just put it in the middle. I know I'm going down at 8-to-1, but it's a quadratic that's up. And the vertex is at 1, -15, and it all looks pretty good. It all looks pretty good. So there's good reasons to think that that's correct. Did I have that on my sheet? If not, I should throw this away and start again. Yeah, I did. I did it in a slightly different way, but we're good. All right, perpendicular. Perpendicular y equals -3, 5 over 2. And I didn't say, I don't remember what it was through, so I'll do through AB. So if I wanted to pass through AB, I got to get rid of A. Subtraction does that, bringing in B. And there's the perpendicular. You might ask, how did I know just to write it like that? Because I've done it for 47 years. All right, but to prove that it's true, we're going to take the 35y, put it on the other side. We're going to look at 2x minus 9. We're going to look at rate of change. Perpendicular is all about rate of change, which is 2 over 35x minus, we don't care about the constant. If you think that -9 over 35 is changing, if that number starts to change on you, let me know. I've got a lot of people in the area that can help. So you keep looking at that. If that number changes, email me, please. All right, perpendicular in class. I hope we went over it. I'm trusting we did. It's the negative reciprocal. And so -35 over 2 is perpendicular to the original line, which is written in standard form. So the inverse. Mechanical way to get the inverse is quick and easy. So another way of writing f of x is y equals. So we're going to switch the x's and y's. So So I'm going to call this x. I'm going to call this y. And now I'm going to solve for y. And if I do, I have found the inverse function. So what's the first thing I'm going to do? I'm going to subtract 5. I'm going to multiply by 3. And then I'm going to divide by 2. There's your inverse. How do you check an inverse? Yeah, pick an easy number. Let's put 6 in here. So 6 divided by 3 is 2. 2 times 2 is 4, plus 5 is 9. A 6 gets a 9, which means in here a 9 should give us a 6. 9 minus 5 is 4, times 3 is 12, divided by 2 gets us a 6. We're in good shape. That's not a formal proof for inverses. It's a quick way to find out on a test if you're right or wrong. All right, so now we're over here. Remembering to pin the video. It is 25 after 1. I think I'm going to be able to do this before 2 o'clock. So what's the slope of this line? That tells you whether you're increasing or decreasing. You know, a linear function that is horizontal it's not increasing or decreasing, which means the y values aren't changing. It doesn't matter what you do with the x's. The y's stay the same, constant. If the linear function is tipping to upward, then the y's are getting bigger as your x's are getting bigger. And the more it tips, the faster that happens. And consequently, the inverse below, decreasing. So I already know that the perpendicular is minus 2 over 7. So therefore, the negative reciprocal is 7 over 2. You can prove it. You know, move the 2y to this side, ignore the constant 7x. So there's your 7 over 2. Here's your change in y. Here's your change in x in the table. So this function's increasing at a 7-to-2 ratio. What makes zeros here? 7 over 4. 0 times anything is 0. Negative 7. Put that in, you get a 0. I don't care what the other numbers are when you put a negative 7. It doesn't matter. Multiply by 0, you get 0. And of course, negative 11. So those are critical numbers, numbers that are friendly, numbers that you can spot quickly to say, I know the outcome of this calculation if I use these inputs. The outcome becomes 0. The outcome becomes 0. The outcome becomes 0. So let's do a quick one here. 5x minus 7 times 8x plus 3 times 9x minus 4 times 20x plus 1 equals 0. Okay? See if you can give me the 4 numbers. Do it with me if you want. 7 over 5. Negative 3 over 8. Positive 4 over 9. Negative 1 over 20. Okay, those are all inverse operations. In other words, I'm trying to get quick at how do I solve that? Well, you got to subtract 1 and you got to divide. Inverse operations. Hopefully you can spot that quickly as we move through the session. All right, so now let's hope that you did a bunch of this stuff in Algebra 1. If not, we'll fill in those gaps. All righty. Square root of 28. Square root of 4 times square root of 7, right, which is 2 root 7. You know, I always like to look at the square root of 4 times the square root of 9 equals the square root of 36 to prove that 2 times 3 equals 6 is a true statement. So a square root times a square root is a square root. There's a whole lot easier way of saying square root of 4 and square root of 9. There's a whole lot easier way of saying the square root of 4. There's not an easier way of saying the square root of 7. So this number becomes that. All right, so there's your 25. There's double that product. That's 40i. Squaring that gets us 16i squared. I hope we've talked about I squared. What gets us a product of negative 1? There is no real number. So we look at imaginaries. All right, so this becomes 25 plus 40i minus 16. So 9 plus 40i. Okay, we'll be doing a bunch of those. All right, so the conjugate of this is 5 plus 3i. And 5 plus 3i. So that's the number 1. So it's not going to change the size of this fraction. Sure as heck going to change the look. So there's 15 plus 9i over middle terms cancel, right? Middle terms cancel. So we get 25 minus 9i squared. And so that becomes plus 9. I squared always changes the sign of the coefficient, right? We've got minus 9i squared, which is really minus 9 times negative 1. So this becomes positive 9. All right, so where the heck was I? Oh, add 9 to 25, you get 34. All right. So the question is, am I pushing you too fast? Is it stuff you already know? Is it all new? If it is all new, don't panic. Day one, 4 days of this, we'll have more conversations, and we'll have a lickety-split progress towards giving you a foundation. And if we do these problems every day for the next 5 weeks, you're going to remember them in your next class. So 9i to the 41st, well, I can work with exponents. I know what I squared is. That's negative 1. And if I know I do that 20 times, that gets me up to 40. And if I multiply it by 1 more, that's another way of writing 9i to the 41st. And I know if I squared is negative 1, well, I know what negative 1 times negative 1 times negative 1 is 20 times. I know negative 1 once is negative 1. You multiply it times itself twice, it's positive 1. You do it 3 times, it's negative 1. You do it 4 times, it's positive 1. I think we've established a pattern. An even number of multiplications of negative 1 gets you positive 1. So 9 times 1 times I is 9i. Okay, normally I would do a bunch, but I'm hoping we did some in class earlier. If not, tomorrow, we'll do 3 or 4 of those in a row. We'll do them again on Wednesday, and we'll do them again on Thursday, and we'll keep doing them. And you got until midterm to show me you know how to do it. So I think this was an expansion. So we want 2 times x squared minus 14x plus 49 plus 11. Okay, so you got 2x squared minus 28x. 98 and 11, I think it's 109. Okay, don't be afraid to do x minus 7 times x minus 7 out first to get what's here. But if you look at what's here and you look at what's above it, you'll see a very nice pattern that I hope we already talked about in class. All right, so anytime you've got a variable alone in one equation, isolate it. We isolate it by adding 36, by dividing by 9, and then by taking the square root, which is plus and minus. Why is it plus and minus? Well, let's look at x squared. And let's let it look at a height of 9. Well, I could square the number 3. That gets me a height of 9. Or I could square negative 3. That gets me a height of 9. So you got to try to remember that when you take a square root in an equation, there's a positive side and a negative side. That work. All right, so what do I see here? Y equals what? Well, I can see my first number is 5. Then it becomes 10, then it becomes 20, then it becomes 40. Sure looks like I'm doubling things. How many times am I doubling? How many times? Well, I don't know. Varies. So that much I know already. So then I look at the first number and I go, okay, if I put a 0 in. 2 to the 0 is 1. 1 times 5 is 1. Works for that. I put a 1 in. 5 times works for that. Turns out it works for them all. So that was an exponential function. All right, let's go over here. Gonna make it. Yeah, more than halfway, and we're more than halfway to 2 o'clock. So I'm gonna keep on moving here. Keep on moving. And again, we can talk about any of these tomorrow at greater length. So first thing I'm going to do is subtract 5, and then I'm going to take the square root, which is plus minus the square root of negative 5, which is equal to plus minus the calculators now are putting I after this irrational number. So plus or minus square root of 5. Now, what's going on here? Let's look at it graphically. That's a quadratic that's been moved up 5, rectangular calculation moved up 5, and we want to know when it hits a height of 0. Well, if you think that graph is going through this height, I think you're imagining things. What are you imagining? You're imagining that it's actually going in the other direction. Now, that's poetic license on my part, because textbooks will take you to a third axis coming out from the wall. I think we can get a better view of this by staying in the coordinate system, because those numbers actually work. When you put plus or minus square root of 5i and square it, well, plus minus becomes positive. When you square the square root of 5, you get 5. And when you square I, you get I squared. Well, what's 5I squared? It's -5. And -5 plus 5 is 0. Okay, no, I'm flying here. I don't remember what, yes, I do remember what I asked. I said, y-intercept. Y-intercept means you let x equal 0. Again, are you starting to get the idea that there's some repetition here? What is something to the 0? It's 1. And that gets us 4 minus 7, which is -3. So that is the y-intercept of this graph. And we're going to learn to graph those things in 10 seconds or less. By midterm, you'll be able to do that. All right, what did I ask over here? Minimum. Oh yeah, we're coming back to a little repetition. What's the important x value that goes with 2x squared? Oh, minus b over 2a. Oh, minus b over 2a is equal to what in this case? 12 over 4. And that's equal to 3. Now let's throw a 3 in there. Oh, there's 9 minus, 18. 3 squared times 2, 18 minus 36 plus 7. Oh, I like that ratio of 2 to 1 and opposite. I know that occurs only at the vertex of a parabola that has a up shape, cup shape, up. So what's the y value here? That's what we're trying to find. This is that y value. And it looks like it's minus 18 plus 7 because you always get half of that or the opposite of that. So what was the minimum? The minimum was minus 11. Now, I'm going to graph this again for you, but I'm going to do it from the y perspective. I'm going to graph backwards. I'll show you why you can do that later. So I'm at 7, 0, 7. And then I know I'm decreasing at 12 to 1. You don't know why yet. And it's cup shape up. And so does it look like 3 comma negative 11, I think I said, works? Let's find out. Minus 11 to 7 is 18 units. Going back 3 and then squaring is 9 units. And 18 divided by 9. Oh, doubling the squaring process. That's your minimum, all right. All right, logs. What do you put on top of a 9? You get a 1/3, a half. That's the square root of 9. Square root of negative 1/2. I need to reciprocate too. So let's prove it. So let's go back to, we don't know what you put on top of it. We don't know. So you got 9 to the what equals 1/3. Running out of room, so I'm going to say that 1/3 is equal to 3 to the negative 1. I'll put it over here. That's equivalent to that because all I'm doing is taking 3 over 1 and flipping it, which is what that minus sign means to do. All right, so now I'll erase and put it 3 to the negative 1. I know another name for 9 is 3 squared. Oh, sure looks like 2x equals minus 1. You know, minus 1/2 was correct. All right, we talked today, I hope, it's Monday, and you've had the discussion about the 3 operations of these exponents because we can't work with logs unless we know those 3 operations. What's the easiest one to do first? Is it easier to say 27 times 27, or is it easier to take the cube root of 27? I'm putting my money on that one. What's the cube root of 27? 3. So I still have 3 to the negative 2. I know what 3 squared is, it's 9. And that minus sign means take a reciprocal. That's 1/9. Did you know that 5 times 5 times 5 times 5 is 625, $6.25? Don't know why I said that. Oh, looks like I got 4 of them. Yeah, it looks like if I do the multiplication 4 times, I'm getting that number. Oh, a little algebra 1 coming your way. Product. Well, I know this is a binomial. What do I want to say? I almost said binomial square. So this is a trinomial which can be expressed as a product of binomials. 2 numbers that multiply out to 56. 8 and 7, good candidates. Negative, minus, minus. Back to products equaling to 0. Very helpful. Talk about more y later. So we got an x minus a 6, an x plus a 1 equals 0. So it looks like x equals 6 or negative 1. Doesn't hurt to look at this graphically. That's a parabola that's been moved down 6 units. That's a linear function going steeply up through the origin. Looks like it intersects at a small negative. Oh, yeah. Yeah, and it looks like it intersects further to the right, a bigger positive. I like that. All right, getting there. Getting there. Wonder how long this will take you to do. We'll find out. All righty. So, based on what we did, first few minutes of class, we talked about the value of the exponent you put on top of a 1/2 to get x minus 4 is -3. Well, if that's the exponent I put on a half, why don't I put it on it and set it equal to x minus 4? Well, I'm going to take the reciprocal first. I guess I should put that in parentheses. I'm going to reciprocate first. That's 2 to the 3 equals x minus 4. Looks like 8. Running out of room. Looks like x is 12. Subtraction becomes addition. It was really nice during my teaching career when I looked at something like 3 plus 7 is 10, and then I realized that 3 was equal to 10 minus 7. Boy, that was really huge, that the inverse of addition can be expressed as subtraction on the other side. I mean, that's very different than getting 3 alone by doing subtract 7, and so that when you got equations like 5x plus 2 equals 20, I know addition becomes subtraction. And the same thing, multiplication becomes division. And that's what it means to think mathematically. You're starting to think in terms of inverses. That's one of the things you want to really understand. So that when you get to calculus and you work with integration and differentiation, your brain is thinking in terms of inverses, not the scales of justice, what you do to one side, you do to the other. Okay. May not mean much to you right now, but I hope it does 5 weeks from now. Okay, why did I just erase that? Who knows? So I'm looking at a pattern here. I'm looking at the pattern and I'm going, oh, let's see. Let's see, that changes by 5, that goes up by 1. So that was a 5-to-1 ratio of change. That changes by 2, my y is changed by 2, my x is changed by 10. That's the same rate of change. I wonder what kind of function has a constant rate of change. 18 to 38, that's 20 units of x change, 4. Sure seems like 1 over 5, 1 over 5, 1 over 5, or 2 over 10. Looks linear to me. I don't care which coordinate you work with. I might as well work with 3, 4. We just said the change in y is a 1-to-5 ratio. So I don't care what numbers you put in here. Let's put a 38 to get an 11. 38 minus 3, 35. 5 goes into 35, 7. 7 plus 4, 11. Oh yeah, working really nicely. All right, so I took you through a bunch of questions quickly for practice. It took me a half an hour to do the video and I was kind of flying. So you writing it out, not talking about it, just doing them, probably take you about 45 to an hour. I don't know. We'll talk tomorrow. Find out. What I'm going to do now is show you my answer key. Hopefully, it jives with what we have on the board. If not, I'll check too. So you can take a screenshot of this. Let's see. Is that right? Screenshot. All right. And then maybe, hopefully you can. Let's see. All right. I'll just keep it there and hope you can work with that. I will see if it's better for me to put these together and get them to you. You give me a couple of days of practice here with Zoom and how to get this material to you more efficiently. And we'll hopefully get a little professional development on the old guy's part. All right, I got my battery-powered bicycle ready to take me up the hill, get me home before 2 o'clock. So I'm going to end this and hope that it has been useful for you because I got to upload it. See you tomorrow in class.